All right, in this video, we're going to talk about how we can calculate standard deviations and variances, and in turn calculate z-scores using our calculator. Okay, so if you watched the video on how I showed you how to calculate the mean and the median using the calculator, it's the exact same steps. Okay, the first step is that you're going to enter your data into the list L1. Do that by hitting your stat button, going to the edit menu. I'll do an example in a second. And then you're going to calculate the mean and the median. We're going to use the one var stats, but excuse me, we're not calculating mean or median. We're going to use, we're going to calculate the standard deviation. So to calculate the standard deviation, we are going to use that same one var statistics, the same one var stats. Okay? When the calculator asks you for your list, make sure you have an L1 there. Make sure your frequency list is cleared out, empty. Once again, if you have an older calculator, you need to type L1 when it takes you back to the home screen. But here's a different part here. So remember, the calculator is going to spit out a bunch of information to us. So what we need to pay attention to as far as standard deviations, the calculator is going to calculate both standard deviations for us. What I mean by that is the calculator is going to give you the sample standard deviation. The calculator is also going to give you the population standard deviation. The calculator has no idea whether or not you gave it a sample data set or a population data set. So it's important whenever you're using the calculator that you understand only one of those standard deviations is correct. And it's based off of whether or not you have a population data set or a sample data set. And the calculator does not give us variance, believe it or not, but that's no problem. From previous videos, we understand that to calculate the variance, all we need to do is square the standard deviation. Okay? And so because our standard deviations could be a little long, I'm going to show you a shortcut on how you can copy down your standard deviation. So so to calculate your variance is what you do. You're going to use the steps listed below or above, okay? And then you're going to click on this vars button. I'm going to show you all this in a second. And then we're going to go to statistics, and then if we can select either the sigma s or the sx, that will copy the respective standard deviation to our home screen, and then we can just square it without even having to type in that long number. Let me show you what I mean here. For example, a student of statistics bought various movies and wondered about the statistical properties of the movies. The student converted all the movie links to seconds, and the data have been reproduced below. Calculate the sample standard deviation and the sample variance. Round your answer to 2 decimal places. Okay? So the first thing we need to do is we need to input this data set into the calculator. So let's open up our calculator here. All right. Hope you guys can see that. So remember, to enter your data set, you hit your stat button, and we're going to go to edit. We have data values in there from a previous problem. So remember, to clear that out, you go up to the top, see where the L1's highlighted, hit clear, and then enter. And what we need to do now is put in these data values. So if you need to, feel free to pause the video and write those down. And I'm going to go ahead and put these on in. So the first data value was, I'm not sure, 5,400. 44. 6,400. 5080. Let's see, 9,800. 7,200. Okay, we got our data values in there. Now we need to calculate our standard deviation. So we're going to go to calculate, one variable statistics. Our values are in L1. Our list is L1. So once again, if you don't have that, remember you hit second and 1. That's how you type in L1. Frequency list should be empty. Go to calculate. And here we go. A bunch of values pop up here. And so remember, X bar is your mean. Okay. This sum X here, this is when they added up all of the data values. Yeah, 49,580. The sum X squared means they're adding up the squares of data values. Don't worry about those. Anyways, SX and sigma X. If you can see my mouse here, these are the two standard deviations. But the question becomes, which one should we use? Should we use the 1714 or the 1604? Well, remember in the problem, they told us that the data set was a sample, or calculate the sample standard deviation. So that indicates that we need to give them then the SX. And to 2 decimal places, that's 1714.82. Okay? So this is the sample standard deviation. Put SD there. All right. We also need to calculate the sample variance. Remember, the sample variance is just the square of your standard deviation. Okay? And so this is what we're going to do. So S squared is the symbol we use for sample variance. And this is what I was trying to explain earlier. I want to grab that entire 1714.824023. Well, what if I don't want to write all of that? That's a lot to write. This is what you can do. Go over and hit the vars button. It's right beside your clear button. If you hit vars, it's short for variables. And then if you look at number 5, statistics, so either you can move it down or press the number 5. Now we have these statistical symbols in which we can select. So we want to square our sample standard deviation. That's the SX. That's that number 3. So if I go down to 3 or type 3, it now grabbed that entire long standard deviation number, and we need to square it. So I'm going to hit my X squared button over here on the left side, and that is going to square my standard deviation to give me the correct variance, which is, 294,061. 294,0621. Let's go 2 decimal places, 0.43. Okay, this is your sample variance. Once again, can't stress it enough, folks. Make sure you understand whether or not you're working with a population or a sample. That will determine the correct answer for you. All right. There we go, z-scores. So remember that our z-score from the previous video is you take your data value minus the mean and you put it over your standard deviation. Make sure you use the correct standard deviation, okay? Because you need that for your z-score. Okay, so we have 2 football teams. Their scores are provided in the data set below. When the 2 teams met in the 10th week, Team A scored 14 points, Team B scored 35 points. Treat the given data sets as samples, okay? Which score was more unusual in that game? So use your calculator to calculate the z-scores. Okay, so I'll tell you what, I'm going to pause the video, so I don't want to take up a bunch of time putting in these data values. What I'm going to do is I'm going to take the data values for Team A, and I'm going to fill them into L1, and I'm going to take the data values for Team B, and I'm going to fill that into L2. All right? And so what I'll do is I'll pause the video, and then I'll catch you guys in just a second. Okay, so we're back. So let me go to my calculator. I have all the scores for Team A. I've placed those into L1. All the scores for Team B, I've placed those into L2. And what I'm going to do here is I'm going to calculate the mean and standard deviation for each of those data sets. So to do that, we're going to do stat. We go to calculate one var statistics. So let's start off with team A, which is located in L1. If we go down and calculate their statistics. Okay, we see that their mean is 24.2. Okay, so I'm going to write it like this. X bar for team A was 24.2. So the mean for team A was 24.2. And the sample standard deviation for team A, because it says treat them as samples, is, let's do 9.10. Let's do 2 decimal places. Okay. Now, let's go ahead and do the same thing. Let's calculate the mean for team B and the sample standard deviation for team B. So to do that, we're going to redo our one var stats and clear this. This time for team B, my data set is located in L2. So that's going to be found by pressing second 2. Okay. And here are the statistics for team B. So their mean is 18.4. Right. And their standard deviation to 2 decimal places is 16.57. Remember, we're using the sample standard deviation for this particular example. Okay. So as we talked about in the previous video, I can already tell based off the standard deviations, Team A scores more consistently. What I mean by that is Team A scores are closer together whenever you compare them to Team B's, because Team B's standard deviation is larger. All right, so here we go. Let's calculate some z-scores. So Team A scored 14 points in that game. So the 14 points will be the z-score for Team A. So the z-score for Team A will be 14 minus the mean of 24.2 divided by 9.10. Okay, I'm going to put this actually in my calculator I have beside me here. So if you do 14 minus 24.2, divide that by 9.1, you get a negative 1.12 as a z-score. Okay. On the other hand, the z-score for Team B is they scored 35 points. So we're going to take 35, subtract away the mean of 18.4, divide that by the standard deviation of 16.57. Okay, if you're at home, please double check my calculations here. I got a z-score of a positive 1.00. Okay, so the question is, which score was more unusual? And as we talked about in the previous video, unusual means, think of a number line, think of 0 being your center point. Which z-score is farther away from that 0? Okay, you have Team A, which was negative 1. So ZA was negative 1.12, and then you have Team B, which was a positive 1.0. So you can see that the z-score for Team A, that's farther away from 0. Therefore, Team A had the more unusual score. Okay. Team A had the more unusual score. All right, there we go, folks. That's how you're going to use your calculator to find standard deviations. And then once you have these standard deviations and means, you're able to find the respective z-scores. I will see you folks in the next one.